everybody. I'm heading out this afternoon, just after 12 o'clock here, over to a house where the complaint was there was smoke and a bang, and we don't know what happened. At first I thought it was, I've been out there once already. At first I thought it was going to be a compressor terminal and the smoke was refrigerant since this was the summertime. But it turns out that the PTC start assist in this old Goodman unit had, I guess it overheated, it melted the back of the panel a little bit, exploded, and pretty much toasted everything in the control cabinet. We'll take a look at it when we get there, but we're going to end up rewiring this control cabinet. Basically installing not a PTC, but a 521 hard start instead. Install a new Defrost board, just an old generic Defrost board from Goodman. Put in a new contactor and capacitor because everything was charred, kind of brittle. So not really any way we can use it and rewire everything. Alright guys, here's our CPKJ30 from 1999. Let's take a look at the compartment here. It is toasted. Everything's burned up on the inside of here. There's the PTC, or what remains of it. You can see the back is blown out, and there's actually a hole right there where it melted through. It blew out. The capacitor is falling apart on top. The defrost board maybe just covered in soot, but we're going to go ahead and change out all the components in here to make sure everything's safe and rewire everything. So we'll have our work cut out for us. We'll take it one component at a time, and y'all can follow along. I removed the capacitor. You can see where it's still silver, where everything blew up around it. Remove the PTC, it's going to stay gone. We're going to use a 3-wire hard start instead. I'm going to take the defrost board down and kind of lay all the components out of the way, put the new ones on there, clean things off a little bit, and then rewire them up with some new wiring, or salvage some of the existing wiring. Maybe we'll take a look at it, but a lot of it's going to be replaced. We have our old components laying out front here, and the new components are arranged. There's our new contactor, single pole. There's our new dual run capacitor. We have our hard start, which takes the place of the PTC up top. It will fit, kind of dangling right there, but it will fit inside the cabinet. Then we have our defrost board. So what we have to do now is go wire by wire, kind of check them out, see if what condition they're in. Some of the ones running from the inside of the cabinet from down here, we're going to verify that they're good enough, then rewire those. Ones that are in transit in the cabinet, like any jumpers from the capacitor to the contact or anything like that, we'll go ahead and replace those since they were all in the cabinet. We'll see how it works out. Hopefully most of them will be good. We'll replace whatever is not good. First thing we'll do, guys, is we'll follow along with the drawing and wire up the dual run capacitor. Of course, our black here will go to the common side of the contactor. Our yellow will go to the hermetic side of the capacitor, and then our red will go to the common side of the capacitor. So we'll go ahead and probably shorten those up and wire them off, and then move on to the next thing, one thing at a time, so we don't get overwhelmed with all the wiring we have. We have the first 3 wires wired up. Our black from the hard start potential relay going to the common side of the contactor, and we have our red to the common, and our multicolored basic yellow wire to hermetic. So we're going to move on to wiring up some of the compressor wires to the contactor, starting with some that go to the capacitor, and then moving on to the contactor itself. This is the old capacitor. As you see, it's sustained quite a bit of damage here. So of course we're not reusing any of that wiring. It's damaged beyond repair, and of course the PTC's exploded, and PTC isn't really, I'm not a huge fan of the device anyway, so I just used a hard start kit. So we're gonna get rid of that and keep on wiring the contactor in place and wired up. What we have here is at the bottom we have our 240 volts feeding from the disconnect. Directly behind each one of those legs, on that same leg of power, so we have, we have our L1, L2, if you want to say that. There's one coming off L1 behind here and one coming off L2. That's the crankcase heater. And there's a few different ways to wire the crankcase heater, but in this scenario it stays on pretty much all the time. Sometimes they're cut on and off by a discharge temperature switch, and sometimes they're wired in just so they're just on when the unit is offline, but in this case it's on all the time. On either side of the contactor, you'll see low voltage wiring. One of them is not on here yet. This is a Y1 signal. And we have our commons on this side. You have 2 commons, and then you have a black wire here. That's the only thing that is serving as a common for the reversing valve. So it's just kind of coming off there as a jumper. Sort of like a little intersection for all the common wiring. Next, we're going to move on to the defrost control board, wiring it up. This will be one of the rare ones that uses the run winding on the switch. A lot of times it uses the common wire, or the common winding wire on the switch for the defrost board, but this one actually uses the run winding wire, which is a red wire, but we're going to redo it so it'll be black. So we're going to get that wired up and kind of go over what we did there. Here is our old defrost board, as you can see. It doesn't look, there's a little bit of, charring here and there. Very similar to the model now. The components are in the same, or the wiring terminals are in the same area. What we do is we have our row along the bottom. Our right 2 reds here are the defrost thermostat that clips onto the outdoor coil. We have our 3rd red, which is our power coming into the defrost board. We have our white wire there's on W2, and that wire right there will send a signal for the heat strips when the unit goes into defrost. And the next 2 are both O. One of those is the orange wire coming in from the thermostat wiring field connection, and the black one to its right, which is, if I can get there, right here, is the wire going to the reversing valve itself. And the next 2 are pretty easy. They're the Y and the common on the board. And that will run down to the contactor where we have tied it in. So all that we have left is the outdoor fan motor, but I'm going to take the top off and kind of clean things out a little bit, and then we'll tie that in and start her up. Alright guys, we scooped some dirt out of the inside of the unit, that big pile right there. And what happens is the dirt piles around, and well, leaf matter and organic things pile in there, and then they become dirt over the years. And then once they become dirt, they start causing all sorts of problems at the base of the condenser. And this one's rusting out a little bit around the edges because it's been sitting there for so many years, but there's not much you can do about it now. So we have 3 wires coming from the outdoor fan motor we had to hook up. We have the purple, which is the common, it's going up there to the defrost board. Like I said, it's the common on this particular layout. Like it's broken by the defrost board. We have a black, which is the common winding of the motor. Right here. The purple is the run winding. Common winding going to the contactor. And then we have our final wire, which is brown. Here we are. And it goes up, if you can see it right there at the back of the capacitor. It's hard to see, but it's right there in the fan terminal in the back. It's hard to see from here. So we're all wired up. This will get tidied up a little bit once I see everything's going to work out all right. I had to replace the fuses and the disconnect. Obviously they blew whenever everything got melted together. And then we'll start things up. We are watching it now. The unit just started up. 253 over 87. This is an older unit. I don't believe we have low airflow. I believe we're a little bit overcharged because we are running at almost 87 pound suction pressure. Typically, if you have a low airflow situation, you'll have a low suction and low superheat. But we're probably just overcharged here because the subcooling is so elevated as well as the discharge pressure. But we're going to have to take a look inside and see what our target superheat is, because it is hot today. It's supposed to be in the mid-90s, and so that will run a superheat down, but only if your temperature is down in your house. So we'll see. We should be pretty warm inside here, even though they have a window unit. So we'll get our target superheat and compare, and then make a decision. I have my new field piece meter, because believe it or not, I told some of the guys on Google Plus, I actually ran over my meter with my truck. I don't even know how to explain how that even happens. But I got a new meter, SC57. It's very similar to the one I had before, except it has a wireless feature. So what I have is I have my wet bulb probe at the return inside the house. Give me my wet bulb, so I can then calculate my superheat, but I'm pretty sure we need more than 0. Yeah. We need a superheat of 21. So we look like we're just a little overcharged. We'll try to recover a little bit of the gas into a recovery cylinder using the force from the compressor to recover it. See if we can't get a little bit of superheat out of the system. and then we should be pretty much finished and wrapped up for today. A little bit better numbers here. We took some of the refrigerant out. Got a 10.8 degree superheat coming up a little bit. I'm kind of hesitant to take out any more of it. This guy wants to sign up for preventive maintenance, but he's not home right now, so I can't really take his stuff apart and clean it just yet, because that's what we really need to do to finalize it. I just know that if we leave it here with no superheat, that's where our accumulators get rusted out, and this one doesn't look too good to begin with. And of course, it's not very good for the compressor as well. So this is an old reciprocating compressor, and they do not like liquid, so we don't want liquid getting back there. But I'm gonna call this good for today. We're gonna come back and hopefully clean this thing inside and out, because it is a 1999 unit, and I'm sure it's been cleaned exactly 0 times in its lifespan. So we'll see you guys on the next one. Have fun out there. I bleed for my money, day in and day out. I try to give you the things you deserve, but I'm just a college dropout gives his weeks to break the mean. Fall